All right. Assuming that we are good to go, I'd like to thank everybody for joining the webinar. Good morning, good afternoon, good evening. Welcome to our event, Built for Trust, Engineering Solutions Against Counterfeits. I'm Greg Jack Nunes, Senior Product Manager at Accuris for our Supply Chain Intelligence Division, and I'll be the moderator for this event. A couple of housekeeping items. You can use the chat function at any point to ask questions during the webinar. We've reserved time at the end, so we'll get to as many questions as possible. So we'll have around 15 minutes to have some interaction with our guests today. You can also access the Resource Center in the Zoom interface, where you'll find some great content, including the chipsID Counterfeit Electronic Parts Mitigation Strategy Guide for Aerospace and Defense. If you look, I think in the bottom right-hand side of the interface, there's a Resource Center link, and there'll be some really great stuff in there. I'm also thrilled today to be joined by Lam Nguyen, CEO and co-founder, and Adam Hook, co-founder and CRO at chipsID. So welcome, Lam and Adam, and thank you for taking the time to speak with us today.
Thanks, Greg, for the introduction, and hello, everyone. My name is Lam
Fantastic.
Nguyen. I'm the CEO and founder of chipsID. Thanks for joining us today. By the end of the presentation, I hope you see how the partnership between Accuris and chipsID elevates your company's quality and customer trust like never before in combating counterfeit electronics for aerospace and defense. Together, we're proud to be the first in the world to deliver this proactive engineering solution.
Awesome. Thank you, Lam. And thank you, Adam, for joining. This should be a really fun event. I really look forward to the insight that you're going to bring into this topic today. So if we look at end-of-life information within the Accuris system, we see at Accuris an average of 52 electronic components go obsolete every day out of our library of about 1.2 billion parts. This introduces risk when sourcing parts, obviously. Lam and Adam, can you articulate what this means in practical terms?
Absolutely, Greg. I can absolutely address this one in terms of practicality. But first and foremost, I would like to congratulate on the milestone of over 1.2 billion electronic components in Accuris database. And that is something Accuris should be very proud of. As a component and reliability engineer, I've been using the tools for over 20 plus years, going back to 4D Online, IHS, and now Accuris. The transformation is mind-blowing to now implementing AI. So it is an honor to be a partner with Accuris. In practical terms, this means that every day, designer, manufacturer, sustainment team lose about an average of 52 parts that they may be already using or planning to use. For designer, the bill material can become invalid overnight, forcing redesign, requalification, or last-minute substitution. For quality, replacement part may not be equivalent. For example, designer need to downgrade their part from minus 55 degrees C to 125 degrees C temp grade to an industrial grade part of minus 40 to 85 degrees C, or even worse, right? From 0 to 70 degrees C using commercial grade part. And that increased the risk of performance issues, failures, and compliance problems. And for cost and schedule impact, you have obsolescence driving higher procurement costs, production delay, and extended downtime. So for procurement, and lastly, procurement and supply chain, they're pressured and pushed toward last time buy. But as you know, last time buy isn't an easy execution without a strategy. So ultimately, the path of least resistance, but the highest risk is to turn to the open market parts, where availability, Greg, as you know, is always available, but then the part integrity and quality is uncertain, and the counterfeit risk is extremely high. So all of this may sound like the sky is falling since it directly impacts cost, schedule, quality, and customer trust. But if we take a step back and break down the problem to a manageable size and approach it with a proactive mitigation at the design phase. So for the first time ever, we take in counterfeit mitigation during the production or end of life phase. We bring it up to the front at the design phase along with the bomb scrub. So that is how we can achieve low risk and high confidence level, Greg.
Fantastic. Thank you, Lam.
Yeah, workflow has evolved, and that worries engineers. Engineering teams now manage a broad range of uncontrolled variables and critical risk factors, such as the new aging problem, where original component manufacturers and franchise distributors are shipping 5-year-old stock. This introduces immediate concerns regarding corrosion, solderability, and long-term life cycle uncertainty. There are concerns with process and material variation as well. Changes in mold compounds and manufacturing locations happen based on supply availability. While technically authentic, this creates parameter drift that challenges physical signatures. There's also spec grade volatility, as Lam mentioned, where market demand is driving a surge in remarked speed grades, and this increases the occurrence of performance risk, warranty liability, and authenticity gaps. Our primary challenge isn't just malicious counterfeiting, it's the erosion of technical certainty.
That is a great insight, Adam. Thank you very much. Let's pause for a quick poll question. I think a poll should pop up on your screen. And really, we just kind of gauge the audience. How confident are you that you can mitigate counterfeit risk in your supply chain or counterfeit risks today? You have one quick vote. Ooh, I love how these polls change. It's back and
Yeah.
forth between somewhat confident, very confident, no confidence, and low confidence. But right now, far and away, somewhat confident seems to be leading the charge. And we do know that there are resources out there. There's a number of organizations like GuideUp, like ERAI, and others that provide counterfeit notice information. But as we'll sort of see in our presentation today, there are other methods that provide an unbelievably accurate way of comparing OEM, original equipment manufacturer parts, and those parts bought on the open market today. So right now, then, overall, 62% say they're somewhat confident. I'm hoping that at the end of this webinar, we'll actually see that you will understand that there is a path towards an even higher confidence factor that we can all become very confident in this. So fantastic. Thank you for sharing results. So this is just a quick share. Let's move on to the next section. So Adam, tell us about the risks purchasing from independent distributors.
Yeah, certainly. So this is where procurement terms create systemic engineering risk. So industry average return windows, which is 16.5 days, are often shorter than our verification cycles. And this means we're timed out before we can even prove the part is good. Many contracts mandate seller-only testing, which can lead to verification bias. And this creates a conflict of interest where the party providing the evidence is the one incentivized to reject the claim. Without a gold sample reference or exemplar, standard testing peaks at roughly 87% confidence, and that 13% gap is a massive blind spot. Buying on the open market without a verified reference isn't just a supply chain move, it's a high-stakes engineering decision.
So what are the options? I mean, what are some of the risks versus the benefits when we look at this?
Yeah, so right now engineering teams are forced into a trade-off between two unsustainable models. We have reactive validation or technical debt, and this is testing in a vacuum. Even when adhering to AS 6171 or AS 5553, you're often chasing a signal in high noise. Without a known good baseline, these tests frequently return inconclusive, and you may be spending thousands of dollars and weeks and hours of time and still end up with a high risk maybe. Manufacturing companies building forensic labs create operational bloat. It requires massive capex, hazardous decapsulation capabilities, and specialized staffing. More importantly, it doesn't scale. You're constantly hunting for verified obsolete parts just to build a reference library that's outdated by the time it's indexed. You're forced to choose between statistical guesswork or becoming a full-time forensic house. Neither modality supports a modern, high-velocity engineering cycle.
Now, we've worked together for some time, and you've recently shared with us a really novel approach that you refer to as EPIC. Can you dig into that a little bit and tell us about the EPIC approach to mitigate counterfeit risk?
Yes, Greg. Believe it or not, this slide is actually what inspired me to start chipsID because it exposed a critical gap in probability of detection. And more importantly, the fact that no database existed today to truly address that, right? So at the moment, I had three choices. Doing nothing was never on the table. Building a database that is half-baked, unmotivated, and mixed with DUTs from DUT, I'm referring to as device under test, open market parts, from eBay, Amazon, Craigslist, or even silver sample, where you only test certain parameters on the datasheet against a golden sample and a couple of golden sample. That would introduce a very serious risk around traceability and data integrity. So that left me with one viable path is to build a true golden sample database from the ground up and from the heart with passion, with the right safeguard and trust and must-have feature in there, or don't build at all. So these are the features. It's called effective, proactive, privacy-focused, intuitive, and collaborative. So how is it out of 1.2 billion parts? How can we create a database that when you log in, it is 100% matched to your parts list or your BOM? So in order to be effective, we have to work with you, right? We work with you by telling us to what are the part of the catalog, the COTS part number. So we're not talking about proprietary part, SCD, or anything like that. These are just COTS part number. And privacy focus means we allow you to choose the part to share in the database or not. And intuitive, meaning the database has to be easy to search for a part based on description or part number. And we also built in a comparison feature for you to compare. And lastly, the collaborative feature, meaning let's say your company missed the last time buy and another company happened to bought that part and catalog with chipsID a golden sample. So now at least you have one point of reference for a golden sample for comparison. So today, I'm proud to say that chipsID is the world's first golden sample database for proactive counterfeit mitigation. With Epic approach, we can now complete the probability of detection without skipping critical visual inspection. So once everything checks out, then you would proceed with electrical testing, not skipping the visual, test the part, and then say, you know what, it's the wrong die in there. So that's not the approach. We want to be proactive, right?
Exactly. And I love the foreshadowing as well, Lam. I'm knowing what's coming next. I'm really excited to also get into the demo portion of this where we can see exactly the chips ID approach and the accuracy of your information. So let's talk a
Absolutely.
little bit,
Thank you.
yeah, let's talk a little bit about the proactive approach to reduce risk. I mean, Adam, you have some real insight into this area.
Yeah, thank you. So most organizations treat counterfeit mitigation as a crisis response rather than a technical specification. Your leverage over risk evaporates the further you move down the life cycle. So you have development or the design in phase. That's where you have the highest return on investment on certainty. Proactive verification is a buffer against system-wide failure. And catching a pedigree here isn't a minor BOM update. It creates legacy of technical debt. So we really want to make sure that you get the information that's accurate, that's easy to reference at the development phase. You also have production or the scaling phase, which is when the line is moving, we're no longer just talking about part costs. We're talking about line down penalties, engineering hours, loss to troubleshooting, failures, and catastrophic recall exposure. There's also the sustainability or end of life, which is the survival phase, which we're all very familiar with. And this is where the lack of verified reference becomes a total bottleneck. So without a gold sample or exemplars to validate against, you're forced into expensive, unplanned redesigns or high stakes, low trust, gray market sourcing to fulfill contractual obligations. If your verification strategy starts at the line down event or EOL panic, you've already lost. You need a verified pedigree from the first prototype, or you're just building on a foundational technical debt.
Awesome. Let's take a look at sort of this in practical steps.
Certainly. So let's do a quick gut check here. You have two parts on the bench. The markings are plausible and the lead surface finish looks new and authentic on both. Now look at these parts and ask yourself, are the differences normal manufacturing variations of the same part across different plants and materials? Which one are you willing to stake your reputation on? Without a verified exemplar, you're not making an engineering decision. You're rolling the dice or flipping the coin. I want you to lean into that feeling of uncertainty. That pit in your stomach is exactly where your teams live every time the supply chain gets squeezed. So now we have the same exercise, a different package. Take a look at these ST micro transistors. One of these is a legitimate part, the other is a clone. Which one are you willing to sign off on? And be honest with yourself, how sure are you which is the real part? 70%, 80? In our world, just 10% uncertainty is where catastrophic failures live. When you're up against sophisticated remarking or OCM, legitimate process variation, intuition is a liability. What you need is a verified baseline. The stakes of counterfeiting components increase as complexity increases. External inspections can validate packaging and markings, but they stop at the surface. They don't prove internal construction. Here's the cybersecurity hardware trust angle. If you cannot verify the internal dies in a component, you're blind to unexpected functionality, substituted design, or hardware level backdoors. If you don't know what's inside the package, you don't have a secure system.
Fantastic. So let's talk about how the chipsID framework supports that verification process a little bit.
Mm-hmm. So chipsID gives you the technical baseline required to verify system integrity with confidence. Here's how the chipsID framework supports your existing verification process. We have verified controls where every catalog gold sample is backed by traceability documentation. Data privacy, as Lam mentioned earlier, your internal work remains private. Only exemplar gold samples are publicly searchable. Your DUTs, your custom components are only accessible by your team. We target high-risk gaps. 38.5% of our growing library is obsolete or not recommended for new design. We provide up to 100 megapixel and 1,000 times magnification exemplar images, so the finest details can be used as supporting evidence. So to help with your internal compliance, we offer gold sample reference reports, and these offer a documented, defensible record to supplement your existing quality management system.
So Lam, can you expand upon that one? Can you sort of dig into a practical example of what this would look like?
Yes, a practical example would be better to just like, you walk through a design with the design, right? So that's the best way. So here's an example as a courtesy of ChatGPT, so nothing is being proprietary, being reviewed. So the fan controller example here, just to show you how we work with EE Designer once they have selected a COTS part. So we do not expect you to share with us your design or any proprietary information. We do not need that for counterfeit mitigation purpose. For effective and proactive feature to truly work, supply chain consideration must begin at the design phase. So this ties back to the second slide where you showing the 52 components go obsolete every day. However, there's no reliable data on how many part numbers are impacted daily by supply chain disruptions. So because of factors such as natural disasters, geopolitical events, tariff, and rare earth material shortages are inherently unpredictable. So that's why supply chain risk should be part of the design checklist.
So at this point, I'm an engineer. I have done all the necessary checks, but I still have some supply chain risk. I can see that golden sample for counterfeit risk mitigation is not available yet to me. How would a typical workflow look like at this stage?
Okay, so the typical workflow always begin at the BOM level. So let's continue to use the BOM of the example fan controller. So when looking at this BOM or parts list, I see three scenarios. The first scenario is address obsolescence for legacy or existing system. If you have 1 to 2 years left of sustainment and you're low on funding, figure out your projected demand and procure part that still honor last time buy, because buying from authorized should always be the priority. Next, you explore the availability from the open market with golden sample reference. That's the key. If you don't have the golden sample reference, then you may need to use one in your system in service or engineering lab, right, for golden sample access. The second scenario I would see from this is to opportunity for redesign. Sorry, going back to the previous slide. Great. So, the second scenario is to the opportunity for redesign the fan controller because of new program or new contract by similarity, right? So basically you only redesign out the obsolete part because you want to keep the rest because of proven operational reliability and not predictive reliability. And the third scenario when looking at this BOM is the opportunity to redesign from scratch because of proven poor reliability from lesson learned. So most likely apply to like a startup company or so, where they just put something together to show the customer a demonstration, but it's poor reliability. So they have the opportunity to redesign from scratch.
Excellent.
Next slide. Yeah. So this is where we apply scenario 2, where the new program reuse this board due to proven record of reliability. So we redesign out all the obsolete part. For new part, we would advise to check with Accuris part attribute to see if the chipsID already has it. And if not, then we can have your procurement team or component engineering team send the part list of COTS part number to chipsID, and we'll catalog them. And once they catalog, we would feed that information back to Accuris to update the attribute value that chipsID has a golden sample. So here is a screenshot of what it would look like if the part is, if we have a golden sample, then it would be view at chipsID for the value. And if we don't have a golden sample, then it would be request part from chipsID.
Great. So at this point, actually, this is like the exciting part for me as well, because I love seeing this in action, but maybe we can walk through a live demo of the process where you find the information, how it relates to chipsID golden samples, and kind of the customer experience at this point between the Accuris and the chipsID systems.
Absolutely. So before I transition over to the demo, I would like to recap again that Accuris and chipsID deliver a comprehensive solution to effectively combat counterfeit electronics. Accuris provides an extensive parts database to support component selection during design phase. And once those components are selected or chosen, chipsID will step in to catalog them. So while it's true that chipsID has the capability to encapsulate unlimited number of parts without using ACID, opening all 1.2 billion parts would be impractical, especially when any single company uses only a small subset. So instead, we take a strategic approach. We focus our resources where they matter most by partnering with you early in the design phase. So I'm going to take you through the part intelligence now. So I'm going to switch over to my screen.
I'll stop sharing.
Okay. Share. Okay, let me know when you can see my screen.
I can see it now.
Okay, perfect. So this is the welcome product page from Accuris. And I like to leave it unhidden so I can see what's the latest news from them, is that they have the US tariff data integration for electronic components. So that's pretty cool. So now I'm going to take you through a robust counterfeit mitigation inspection process that I personally, or chipsID personally, conduct, and illustrate why combining Accuris and vast data intelligence with chipsID golden sample database establishes the highest level of confidence before moving into electrical tests. So we're not telling you to skip electrical tests once you pass visual, but you have to pass visual first before you proceed to electrical tests. So let's go ahead and apply scenario 1, where we're buying obsolete part for sustainment and legacy program, where the customer wants saying, I need 100 pieces of this part number, so that way you can deliver the last few systems to us. We already have a plan for our future program. So let's go ahead and do that. So I'm going to go ahead and take a look at the obsolete part from onsemi that is on the fan controller example. So you can either enter, look like I may have timeout. So you can either enter the part number here or here for Accuris, and you can click search. And obviously that this part is obsolete. So you can see the total inventory is 0. The year to end of life is 0. So before I proceed, I want you to write this down, or maybe the 4 critical steps that you do for counterfeit inspection process. Step number 1 is, you're going to open market. You need to check availability from the open market and the in-house capability for providing preliminary test report. And I'll show you why that's important in a minute. 2 is you verify the alert documentation for EOL, PCN, as well as counterfeit alert report. The 3rd step is to verify data sheet for top marking variations. And the last step is to retrieve a golden sample. So step 4 and step 1 sort of tie together, right? You want to see the preliminary report first from the open market. If it matches the golden sample, or it would give you a higher level of confidence before you commit to a purchase of the part. Otherwise, once the part enters your facility, you will have to write up a guide report because now the counterfeit part have entered your facility. So let's go ahead and click on this $ here from Accuris. That will give you the inventory available. So obviously this part is obsolete. So there's no part in the authorized distribution. So anything that's non-highlighted would be the non-authorized distributor. So it looks like we still have stock. So that's good. But now we need to perform trust but verify, right? So the next step I would do is to look at the alert of the part. So in the alert section, you have EOL, you have PCN, you have counterfeit reports. So just because the part is obsolete doesn't mean that you cannot buy part from directly from the OCM. Sometimes they offer last time buy. But unfortunately, in this case, the last time buy date is already expired. But let me go ahead and pop up this EOL anyway for you to see. So this is the product discontinuance from onsemi. They issued this in October 2023, and the last time buy date is December 2023. So you really only have 2 months to act quick. And you know, last time buy execution isn't easy again. You have to get program managers' signatures involved in order to execute a last time buy. So in the end, you miss that date, then you have to turn to open market. So next I would check is for PCN to see if there are any notification for PCN. So I can click on that. And you can see that the PCN are sorted in chronological order. And there's the one thing I want to look for is the die changes, right? To see if there are any die change to this part. The two conditions for die change would be either die shrink or the yield of the die. Meaning die shrink, meaning if the OCM can fit more die on a wafer, that means it's more profit for them, right? So they would shrink the die. And two is the die has a low yield, they have to redesign the die, issue a new die, but ultimately they want to obsolete that part out. So in this PCN notification, the archive of PCN, the only thing that I see that's related to the die would be this here, this PCN here, and it said non-conductive die attached. So let's go ahead and launch that PCN. So basically it's here, they just qualify a new manufacturer for the non-conductive die attached epoxy from Eblastic to Hitachi. So it does not impact the physical die itself. So at this stage, we know that there's only one die for this part. So next thing I would do to check for counterfeit report, typically counterfeit report are either from the OCM, meaning a batch may have escaped from the original component manufacturer. So that would be the most reliable one. Otherwise, for word of caution, right, the integrity of the counterfeit report, you have to make sure the level of experience who wrote the report. And let's say, for example, if some kind of report said that this part is counterfeit due to a lead frame differentiation. Well, lead frame can be different if onsemi has multiple assembly sites, right? So sometimes you might have to look at the counterfeit. And also, how do they prove that that part is a counterfeit? Do they have a golden sample? What baseline do they use to confirm that that part is a counterfeit part? So lastly, what I would do is I would check for the data sheets. So the beauty of having a Accuris subscription is that you have the access to the data sheet in chronological order and all the way back to 1999 for this part. And you can see that the first time onsemi introduced this part, I'm going to head and open it, was Motorola. So why am I getting Motorola data sheet for an onsemi part, Greg? Well, it's because you have to do a little digging to find out that Motorola divested its semiconductor component group, which then became an independent company known as onsemi. So for this purpose, we know that this part has one variation of top marking so far. So let me go back to part intelligence. For the sake of saving you all time, 2006 was when they changed the top marking again. They decided to add more information. They added assembly location, year, and work week to the top marking. So the part that we're looking at is the SOT5. And then in 2024, they decided to go back to minimalistic top marking again. So they go back to V9M, M is the date code. But if you look at the asterisk here, it said date code orientation and opposition may vary depending upon manufacturing location, right? So on top of the 3 different variations that we saw, we also have the date code orientation as well. So it makes the investigation very complicated. So but for the sake of example, let's just remove the date code orientation. And we know for the fact that now the part has 1 die and 3 different top marking. So that's why you need a golden sample as a baseline. Again, the data sheet only gives you a graphical representation, not the actual what the part looked like, right? So to access the golden sample, what you would do is you go to part details and you click on additional info. And that's where you can click on view a chipsID. So luckily we have this obsolete part in our database for you to have a golden sample access. But before I navigate there, I want to show you another example why being proactive is a lot better and provide higher confidence. So I'm going to go ahead and click out of this and type in a different part number. And that is a TPS 63900 from Texas Instrument. So look at this. This is your total inventory for a newly designed part. It has 15 years to end of life, right? So you have access to 51,000 golden sample right now. So why not use this opportunity to catalog it? Don't wait until it's obsolete, right? A lot of people tell me, what about my legacy system? Well, whatever you build today is going to be your legacy system 5, 10, 15, 20 years from now. So we're creating a time capsule for future component authentication. So let's go ahead and run through the same exercise for this part. You click on the $sign, and here you see this part has plenty in stock through authorized distributors. You have it from Aero, DigiKey, Mouser, TI Store. So the next thing is to look at the alert. So I wouldn't expect any alert for EOL or PCN since this part is newly introduced and there's no counterfeit report against it. So the next thing I want to do is to look at the top marking. So back in 2020, they did not have the top marking yet because of the preliminary data sheet. And you can always go back to Part Intelligent and click on 2025 datasheet version, and you have to let it load. And you can see that the date code should be 639, right? But they also have the notes here. Note 6 is that there may be additional marking which relates to the logo, the lot trace code information, and the environment category of the part. So how can someone imagine up a part with all this top marking without a golden sample, right? These are all graphical representation of the part. So how can you imagine the logo of the TI? Is it the Texas state logo, or is it they spell out the T and the I? So for this example, let's go ahead and navigate to the golden sample. So I'm going to click on part details, and I'm going to click to additional info. And this time I'm going to click to view at chipsID. So now I'm going to redirect us to chipsID database. So it's going to redirect you to the chipsID golden sample store. So we are not a supplier of parts. We are just helping you build a report. So what you're buying here is a report. So before you make a commitment to the report, we also give you a date code. This is 2339 date code. So you can click add to cart and you can check out the report. To save us time, you get an email, and this is the report that you get from us. You can see that we also disclose the country of origin, the top view. You can see the 639 and the TI logo. So it's not a Texas state logo, it's a TI logo. And also the lot trace code that I talk about and the pin 1. So every part we have with 6 high resolution images, top, bottom, lead, X-ray, dye dark field, and dye bright field. And this is the report for the obsolete part from onsemi that you saw earlier, DACO 2022, country of origin China. This is where they went back to the minimalistic top marking, V9X. So that is the date code and pin 1 marking and the RoHS compliant marking. So also 6 images, top, bottom, lead, X-ray, and dye bright field and dye dark field. So if your team regularly buying reports and doesn't want to manage them, and you want to compare side by side for the DUT against a golden sample, the database subscription will be your best bets along with the collaborative feature. So let's go ahead and navigate to the database. So from here, you can click on the database. So every part you see in here, Greg, are golden sample, right? And the beauty about it is that it's privacy built in, and it's also collaborative. This is where I want to show you all those features that I talk about. You don't need to know who contributed this part. It could be chipsID added this part, it could be company A, company B. You don't care about that. All you care about is I use this part in my parts list. I need to have access to the golden sample. Well, the golden sample is here. So that's the beauty about it. So we have country of origin, all these parts are traceable back to the OCM. So now you can click on this one example. You can see it's much more interactive than the report. You have 6 high resolution images. You can click on it to enlarge and close it out. And down here, we also simulate the digital microscope from Kian's experience. You can hover around the die and you can see the marking for the die as well. So we simulate an expensive equipment into a software version for you. And as you scroll down, you can see the part number, country of origin, supply, where we got it from, date code, and lot code. So let's go ahead and head back and I'll show you another example where we also built in compare feature. So a lot of people tell me, well, with the X-ray, can I tell, do I really need to go down to a die? So the answer is yes and no. So let's go ahead and navigate to that. So the TLE 9250. So the beauty thing about it is once you click on compare, you will see that it's stored over here on the left-hand side, and there's a TLE 9251. You can click on the second compare, will appear on the right-hand side here, and you can open compare. And now you can see the parts side by side, right? Just one character difference. So as a counterfeiter, they can always remark just one character, and you can have a different part. So the one with 9251 would be a bus has a bus weight feature, and 9250 doesn't have a bus weight feature. So as you scroll down, they also have top marking, and the leads looks good, right? You have the exposure of the copper. And so side by side, these are 2 golden sample, and you can see at the X-ray, they're identical. So how can you tell the difference without going to the die for this case? Right? So once you go down to the die, you can see that the top marking for the 0 has 2P15 versus the one that has a bus weight feature is 2A15. So you really have to go down to a die level, because otherwise you might getting a non-bus weight feature and you send it out for electrical test. Of course, the bus weight feature won't be there, which you can already verify at the die level. So let me go ahead and clear selection and demonstrate one other example is to, if your QMS team require a record retention of DUT and outcome, your AS9100 and DCMA auditor will ask for evidence of effective counterfeit mitigation. So here's how you can show them that. So I'm going to clear out everything here. And let's lock the database down to the last 4 digit or the last 5 digit of your company. So now the database automatically filter to just the part that you send to chipsID, right? And so the first example would be this part, the regulator boost from IC from Texas Instrument. So first you show your auditor that this is the golden sample, right? So the golden sample here, based on the data sheet, you should have a top marking of S52B. Okay, so now you look at the golden sample, it has S52B. Typically, bottom marking are not disclosed on the data sheet. So this part has a bottom marking as well. And the leads look good. It has the copper exposure and X-ray. You have 3 Y bond on each side, right? 3, 3. And then when you go down to the die level, you can either click on the full screen here and click on it again. You can see this is national semi die. So why is that? Well, you know that TI acquired national, so that's why they have national die. And you can see the LM2733 marking. Now the top marking of the die don't always correlate with the part number. I'll show that in another example. But let's go ahead and head back now to the database and now add in the DUT. So now you compare the golden sample and the DUT side by side. So now for all DUTs, we have a watermark. Warning, this part is the device under test and not to be used for golden sample comparison, right? So you can see that S52B checked out, pin 1, datasheet didn't say that have to have a pin 1, but it's missing a bottom marking. The leads look good because it also has copper exposure. But when you go down to the X-ray, you can see it has 4 Y bond on the right and 2 Y bond on the left. And when you go down to die level, you see that this die here has a triangle with moon present. And because of our extensive database, we can tell you that we can help you with the forensic evidence to help you determine the likelihood of the origin of the remarked chip based on the die found inside. So we know this die here is a diodes ink die. So the advantage of golden sample is you no longer have to decide speed versus trust. We give you both. We prevent you from buying bad parts until it is proven with facts down to a die level. You can tell the auditor now that you weren't impacted by this counterfeit part because you simply rejected the lot before they arrive at your facility, right? So let me go ahead and prove you that this die here is a diodes ink die. I can clear out all the filter and sort this by diodes ink. And you can see that is diodes ink logo. It's a triangle with moon crescent, and you can click on view part, and that is the triangle with moon crescent. So we know that they have a diodes ink die within that TI part number. But to be fair, that part, for word of caution though, right? In this example, we encounter a counterfeit component purchased from eBay for the study. The part from eBay would say this part is TI date code 2135. Does that mean that the TI date code 2135 are all impacted? Absolutely not, right? Because this part has nothing to do with TI. What if you buy it from the same seller and they say this part is 2323 date code, right? Does it mean now TI 2323 date code is impacted? It's not. So when you have a golden sample, it becomes clearer, right? So one last example I want to demo is the cybersecurity risk. Okay. And you can see here on the X-ray, you have a group of 5 dies. How do you know that the last group is supposed to be there or not, right? What if you have a CPU, graphic card, memory, GPS, right? It's tracking your part and ultimately tracking your system where it goes. So cybersecurity risk is real. So in this case, we extract it down to die level. We can see that the first die is the first row, second die is second row, and the third die is the third row. So with that, that's a wrap for the demo. I hope you see that this tight integration doesn't exist anywhere else, right? So let's head back to the presentation with Greg and Adam.
That's fantastic, Lam. There's one thing I keyed on early on at the beginning of the demo, and there were so many things during the demo that were also noteworthy, but I love the concept of a time capsule. As you're doing this, do it now. You have the opportunity now. Do not wait until it's too late. Yes, there are mitigation strategies you can do, but the minute it's on the secondary market, there's risk. But like you said, if there's 51,000 in stock today, buy some of those, get those to chipsID, get golden samples created of those, and then have that confidence moving forward that you have the right part and your future 10 years from now has been taken care of. I really, really, really enjoy that.
I'm glad.
Cool. So I'll grab the screen back and let me get back to the demo. And then I wanted to ask Adam to maybe sort of like talk some tech for us for a moment. Adam, can you sort of tell us about the like what we're looking at here, like to document a TI device, to see everything that Lam just presented to us in the chipsID interface. What are the steps that you go through?
Yeah, certainly. So we align verification data with the reality of original component manufacturing shifts. So we index records by date code and country of origin. This allows our database to evolve alongside product change notifications. This ensures a baseline reflects documented factory shifts rather than surprises. By integrating Accuris, we pair historic PCN records with physical samples. Accuris provides the lifecycle why, while chipsID provides the physical what.
Fantastic. And then well, let me go back up a slide. In our scenario at the very beginning with our ChatGPT generated PCB, I mean, right now we have gone through all of the validation checks with this now. Every single step we have a check mark against. So if we look at that then from an Epic database growth and part revision perspective, can you talk to this slide?
Yeah, certainly. So compliance demands proof. Bridging the gap between policy and proof is what we do. So the tightening of the frameworks like AS 5553 and DFARS have shifted the burden of proof onto the organization that is manufacturing. So in the audit room, the only currency is documentation. Gold sample reference reports standardize your response to critical auditor requirements. So evidence of conformity, for example, would help you instantly produce empirical data required to verify lot integrity. Also, root cause and prevention. We provide documentation baseline that proves the process is preventing counterfeit reoccurrence is active and it is effective.
Okay. And what about other resources, like external resources? What kind of info is available to people out there?
Yeah, so these traceability documentation, that is upon request, and we have an air gap between what is available online when it comes to documentation traceability and what we're able to provide upon request. And that, again, is just added security because it's easier to counterfeit a document than it is to counterfeit a component. And as we start looking at audits as well, what we're looking at here is, compliance demands proof. And so when we're looking at, an auditor is going to look at, how effective is your counterfeit mitigation policy? And that aligns with AS 9100 and other requirements that you see here. And so just want to remember that compliance demands proof and a gold sample reference reports, that's what helps with the audits.
Fantastic. Thank you, Adam.
Mhm.
So let's talk about some of the sort of risks and values of this approach. I mean, what are some of the things that we see in the industry, and then what are some of the benefits as an outcome of using the golden sample approach?
Certainly. And in the aerospace and defense sector, a single counterfeit event that represents a high cost disruption, averaging $700,000 per occurrence. These fiscal impacts often manifest as hidden costs that surface during intensive failure analysis or requalification, unscheduled field replacements, and the long-term administrative burden of reputational erosion. So mitigation has evolved from a quality nice to have into a mandatory enterprise risk management requirement. So disruptions inevitably strike when schedules are tightest and customer confidence is the most fragile. For compliance leaders, implementing a robust detection strategy is a strong safeguard for operational resilience and business continuity.
Fantastic. So do you want to give us a sense of the ROI that comes from this approach?
Yeah, there you go. So beyond risk avoidance, a mature mitigation strategy delivers four critical return on investment. We have improvement to operational velocity, which drastically reduces line stoppages and administrative noise of chasing suspect parts. We have strong strategic autonomy, so you own your baseline data by controlling your gold samples. You eliminate dependency on specific brokers or test house, allowing for proactive cost management. We have confidence going into audits. As a person who has attended and hosted many audits, I am aware of what this is like. We want to transform that auditor relationship. We want to move from a defensive explanation to the presentation of objective evidence that streamlines the compliance process. And we also want to protect your legacy. You want to protect your legacy. You want to future-proof your programs, establish governance, ensuring that as people move on, the technical intelligence required to maintain a 30-year-old program stays within the organization.
Fantastic. Thank you. So Lam, let's talk about like how long does it take? Is this something speed versus outcome? Does one negatively affect the other? Give us some sense for this.
Yes, absolutely. So there's more to this slide than the speed of cataloging, right? It's about to help you win more contract by flowing down requirements and accountability. We enable rapid coverage for all companies with different sizes because they have limited resources to manage golden samples. For subcontractor, we protect the product by ensuring high quality delivery to the prime contractor. So everyone wins with our solution. Since I want to make this the world a safer place to quality, I would like to announce that those who attend the webinar today will receive a free complimentary access up to cataloging up to 40 parts with a value of less than $10 per part. If the part costs more than $10, then we'd also accept sending us your part with redacted invoice for traceability. So it may not sound like a lot, but if you look at the slide here, that's equivalent to a full self-driving single board computer from Tesla. This is our way of showing our commitment to quality in aerospace and defense. We want everyone to thrive, and that's starting with small to mid-sized companies due to their limited access to resource. For the prime, have you ever encountered a situation where a subcontractor requests for using open market parts? It's not uncommon, but it does happen, and it puts you in a very tough position because you are not the design owner. How would you address that? So here's how we would address that. Request if the test report has golden sample for comparison. If they don't, flow down the counterfeit mitigation action plan and mandate golden sample before contracts award. Ask if the inventory control has batch trace or lot trace to assemblies that use open market parts to potentially recall for recall purpose. Ask if the product test procedure would be able to detect failure down to that specific device. So ideally, a golden sample would provide the highest confidence level.
That's fantastic, Lam. I love the fact that you and Adam are offering, you're encouraging people to use this free service to prove the point that this golden sample approach is sustainable, it is accurate, it is something that people can rely upon in the future so they don't have to worry about it, and then hopefully create their own library of golden samples for use within their organization. I really appreciate you guys putting that up.
Absolutely.
Thank you for that. So how about one more poll question, if we can get Allison or Lindsay to pop up the poll. So now that we've gone through all of this, I mean, I think Lam and Adam have done a phenomenal job of helping us understand that there is a completely different approach to counterfeit risk mitigation other than reports. It's reports plus, it is data sheets plus, it is EOL notices plus, there's always this add-on. So how do you feel confidence-wise that there actually are solutions out in the market that can really help you to get a handle on this? And right now, as the answers are coming in, it is a predominant yes, which is fantastic. A few people say no, and that's something that we would like to dig into. Obviously, you can reach out to the folks at Accuris. You can reach out to Lam and Adam at chipsID, and let's talk about why you feel that it's a no. So based on everything that we've seen, let's understand what else might need to be done in the industry so we can see how we can mitigate your risk, not just what we've shown today. I'd be really curious to see. So if we look at the results, there are a couple of folks who feel still unconfident in this approach. So let's make sure that we have a conversation about this, and then get some details on that. Oh, I just got a note that says it failed to share the poll. Another poll has started. Either way, we have 96% feel confident that this is an approach that is very valuable in the market today. So thank you for giving us the feedback. So Lam, you want to write us out, or Adam?
Yes, definitely. I can close out this here. Our partnership truly embodies the saying, if you want to go fast, go alone. If you want to go far, go together. We're supporting our customer from development all the way through end of life, and that could be 20 to 30 years of sustainment, ensuring continuity for legacy systems, spares, and repairs. We have to remember that delivering system isn't the finish line. Long-term lifecycle support must remain a critical commitment for all of us. Together, Accuris and chipsID have set a new gold standard and raised the bar for counterfeit mitigation inspection in aerospace and defense. Accessing to golden samples should no longer be optional and should be the norm starting today. Counterfeit mitigation is not an area for competition. It's for collaboration to deter counterfeit electronics and ensure our safety. Accuris and chipsID performs the heavy lifting so you can focus on what matters most, innovation. We support industry to keep pushing the boundaries of innovation because that's what moves humanity forward. Thank you all for joining the webinar. Please connect with us on LinkedIn, and if that's what you've seen today align with your goals to elevate quality and strengthen customer trust in counterfeit mitigation, I look forward to collaborating with you all in the near future. Back to you, Greg.
Well, thank you. So Lam and Adam, I always enjoy the passion that you bring to this topic. The work that you're doing with chipsID truly feels revolutionary. It feels different from anything that we've seen in the past, and the approach is just amazing. So if we have a little bit of time left, I'd like to open this up for questions. So I've seen that some questions are coming in the chat. So you can use the chat functionality in the Zoom interface, post a question, and we'll get to as many of these as we can. So let's see, because we did see some. I'm not sure if Adam or Lam, we want to go through some of the ones that have already been posed. Let me just see if I can bring up my chat interface. It is
one of the questions came from Mark Killian, and the question is, can anyone with an Accuris subscription access this feature? And so the database is a separate subscription, the chipsID database. The reports are $60 a piece, And then those are able to be directed from Accuris to that. So it makes a really easy streamline workflow.
Correct. So we get call it a continual feed from chipsID as this information gets created, tied back to our component data out of that 1.2 billion components. As Lam demonstrated, you will see a chipsID reference within our additional info section if that golden sample is available. If not, there's a workflow to request a golden sample. So if we do not have it, we can definitely help you get it. And that's where chipsID will bring in your request and do the necessary work to create that golden sample for you in your account.
Okay, so I would like to address the second question from Quentin White. He said, are you saying chipsID should be used on development only? What about legacy system? Well, for legacy system, chipsID didn't exist, right? But you can still have access to golden sample for legacy system based on what you have on your filter service. But the goal of chipsID is that you want to establish a baseline now. Draw the line in the sand, Quentin. Whatever you build now will become a legacy system. So whatever you build now, golden samples should be available, plenty of them. So catalog them now. So that way you don't have to come back and ask us about what about legacy system. So that's how I would respond to that question.
Fantastic. What else do we have? I'm having some challenges with the chat system. It seems to be not
Okay,
popping
I
up
see another question from Jordan. He asked, does this database include electrical testing result? No, it does not, right? We only help you with the visual. Once you can clarify that you have the right die inside a package of the part before you send it to electrical test. So that the goal is to support, we have all the support in place before you send the part out for electrical. Otherwise, you're wasting your customer time and your time to come back and say, you know what, this is the wrong die, right? You would look, you may be embarrassed to the customer to say that it's a wrong die when the customer said you could verify that in the first place. So that's the answer. That should be the answer for that question.
Okay. I see a couple here. I'll quickly jump to one from Rob Perry and answer it. Are these features tied into bomb intelligence? Short answer, yes. Data element, as we discussed, that's available through the application interface. And then that will bring you to the chipsID golden sample database where you would have credentials to log in and view your information. Latasha Berkeley, please explain the golden sample. Is the golden sample something like production lot testing, or does it differ from that? So Adam or Lam, is that?
Adam or?
Yeah, I can do that. Yeah, so a gold sample is going to be the same as defined by SAE, so Society of Automotive Engineers, per the AS 6171B standard that's still being under ballot right now. And exemplars are from original component manufacturer that have traceability to the original component manufacturer. So if you're buying something through a reseller or a non-authorized distributor, there is an opportunity where in that supply chain, there could be some infiltration of non-conforming or suspect counterfeit parts.
Thank you, Adam. We have one from D. Will chipsID continue adding to the database changes in multiple golden samples based on multiple dies as the COTS parts change?
Yes, absolutely. I can address that one, D. But as I mentioned, right, there's only really two factors for die change. It's either a die shrink or the yield of the die is bad, right? Otherwise, it shouldn't be very common for them to change die because, as you know, OCM manufactures in huge volume. So for them to continuously changing die, that's why we have a slogan, dies don't lie. So to change die continuously, ultimately they're going to switch out to a different part number. So with that should be a concern. So if you have the right die and the right wire bond, you are already 95% there. And the last 5% is just to send it out for electrical tests. And of course, granted, I have to pass the XRF for the lead plating finish. But other than that, if you have the die and the wire bond, you're pretty much very close to authentic part, with the exception that you have to send out to electrical tests. So it's not the other way around, right? Right now, a lot of people send it out for tests first and then come back and check on visual. It's like, that's the cart before the horse. So that would be my answer for that one. But yes, that's why with the collaborative feature, we can have different revision of the part, right? You can see the different marking variation that we talk about, the top marking, but not so much for a die change. But if we do run across a die chain PCN, then we're more than happy to catalog another golden sample into chipsID database.
Yeah, and that's a great callback then to as we were looking through the historical content where we can see, from 1999 to 2015, all the changes in the markings on a part based on the different datasheet information. So, two questions. Maybe one is simple, maybe one isn't. Will there be training available on Accuris? So for an application like Accuris Parts Intelligence or Accuris Bomb Intelligence, we do offer training. We have online certification courses if you're already a customer. However, if you'd like to have more interactive training, you can reach out to us at any point, and we can have one of our training experts, subject matter experts, or sales engineers work with you and walk you through how to get the information you need. From a chipsID perspective, Lam and Adam, do you offer training as well? I mean, the application interface looks very straightforward, but is there training as an option?
So we've done some demos with customers and then help them train their people as well. But we don't have an official training program at this time, but certainly that's something we can discuss.
Okay, thank you very much for that. There's a question, does a report include mean time between failure data? In the Accuris system, we have MTBF and FIT information where available for components. With the metadata attributes, the extra information captured at chipsID, do you also include MTBF, Lam or Adam?
No, so that's where we're gonna piggyback off of Accuris. That's why the integration is so powerful, right? You guys already have an archive of PCN, you guys have archive of datasheet, and also a whole bunch of other parametric search as well. So we rely that on Accuris.
Perfect. Okay, thanks. The question, will the recording of this meeting be sent out? You should be able to access a recording from the resource center. It may take a little bit of time for the video to churn and be made available, but the recording will be available to you after this event. All right, that's what I see on mine. Are there any questions, Lam or Adam, that you see that we need to address or have not addressed? Oh, actually, here's a question from Edward. There's a question if you can be supported or if you can support users in the EU for the free evaluation offer. Are there any limitations to by geographic location as to whom can take advantage of that?
No, actually, that's not too much of a concern right now. And as long as it aligns with EAR or EAR requirements, which is export regulation. So because we work with defense and aerospace customers, we're very concerned about, who is able to access in countries like Russia or adversarial countries.
Awesome. Thank you, Adam. I noticed a message from Tilla. If a part is found to be counterfeit and you have the X-ray available, can you identify based on your database which real die is inserted in the counterfeit part? For example, a graphical search of die pictures.
Yeah, so what we could do is characterize the information if we don't have that as a gold sample, and we can characterize based on country of origin, manufacturer, date code, type of package, etc. But yeah, ultimately, again, we just want to emphasize that you want to capture a gold sample when the parts are accessible and available and they're new to the market. And that allows us to get the best record. So in the automotive industry, not many people really understand this. The first year model that's being released tends to have the highest quality parts. And then as the year model continues, they actually start to try to control costs and cheapen the manufacturing of it. So if you're able to get a representative of when it is built with its highest quality components, then you're able to have the best record to compare against throughout the life cycle of the part.
That's good to know. Keep on top of your components from the very beginning so that you don't run into, well, what happened prior to this. Yeah. There's a question about subscription cost and does it allow unlimited access to reports? I mean, obviously, there's two aspects to this, but let's talk about the chipsID version of it and how you can access reports there.
So the reports are $60 a piece. And as people start to accumulate more reports or they want more interactive side by side or they want higher quality resolution, there's a lot of value getting the database. In the database, we quote based on geographic location, how many sites, how many heads or access we have to provide for accounts. So there's different attributes there, and I don't want to tell you like what the price is if it's different in your situation. So we just recommend that you send an email out to Lam or I, and then we can work with you on that.
Thank you, Adam. Seems that so we are beyond time. I think we're beyond questions. Lam or Adam, do you see anything else that we need to address, or are
And
there any topics? Yeah, please
just
go
one more
ahead.
just pop in. It said the chipsID provide paid service to
Oh,
identify counterfeit part if component is sent to their location. So if we have a golden sample, then we'd be more than happy to help. But with just a DUT, it's just we don't have enough confidence to say that part is counterfeit or not, right? As you can see in our example, without golden sample, it's very difficult. Just like that one part from TI, that is actually a valid part from Diodes Inc., but it just happened to share the same marking as S52B. So if we do the X-ray, we do XRF, everything would come out correct. But it's just that when you buy the TI part, you would expect the TI die inside. So if you send us a DUT and we don't have a golden sample, it'd be very difficult to authenticate. So that's why we want to set a new trend. You want to have golden sample ahead of time for new design system.
Mhm.
So
thank
you
you.
can check against our database. If we have a golden sample, then yes, we're open to decap that down or catalog that DUT for you to compare side by side in the database.
Perfect. Okay. Well, I
Yeah.
really once again like to thank Lam and Adam for their insight, expertise, and their knowledge in this industry. They're truly doing something unique. And it's a comprehensive approach to eliminating counterfeit risk in any supply chain, aerospace and defense, consumer electronics, medical devices, any supply chain applies. So I'd also like to thank everyone who joined the call, who stayed a little bit afterwards, asked questions, gave us that interaction. That's been really, really fantastic. So I do want to remind people to access the Resource Center. The chipsID Counterfeit Electronic Parts Mitigation Strategy Guide is a phenomenal document. And the webinar replay, if you want to go through this again, go through the demos that Lam gave, go through the examples that Adam provided, and just really deep dive into that, and then come back to us with any questions. We'd really love to hear from you. So thanks everybody for joining, and I wish everyone a great day, a great evening, a great morning, wherever you are in the world.
Thanks, Greg. Thanks, everyone.
Thank you, guys.